Alright, should be making a video and such. We'll just do this little pop out the chat crap and blah blah blah. And we should be on our way. Oh, so that's working so far. Alright, we have a video processing. So I'll do a few comments first, and then we'll get to a Huygens optics video where he just talks about light and the context of the different, sort of referencing the experiments, but just the jargon they use to describe what happens to photons or what photons actually are, which is an interesting subject, but totally not even close to accurately described by conventional physics. So anyway, I did respond with the response video yesterday to the physics Michael guy, right? What's that his name? Something like that, yeah. Kind of a nice, polite statement for me anyway. Thank you for the reply. I have made a video response providing counter examples to your example. I think the subject is worth your time and consideration and hope you will continue to participate in the discussion. Thanks again. So, no reply yet. But, the irritating little bit is this John Walker weirdo, creepy fucktard doesn't post a reply to my comment in some way and say, okay, I'm going to do this, whatever. I'm going to, talk shit about somebody else in the comment section. He posted as a regular comment, so again, somebody else reading this has no idea what he's talking about. So he just posts this trolly piece of crap on somebody else's video. He has so little respect for anybody else's video content that he'll do this to it. That goofy person. So how's somebody supposed to know you are talking about another commenter on the video? How are they supposed to? There's no goofy person in the video except the guy making the video. Somebody's going to think you're talking about the person making the video, you idiot. Failed every physics test at high school, so that didn't happen, but whatever. And SE immediately dropped physics after 1 year. So again, that didn't happen either. These are just all stories they make up. She almost drove her physics teacher into insanity. And he's referencing a she. Who's... Don't you can't... You think you know physics and you can't figure out that who do you think is going to read this comment and understand what the fuck you're talking about, you lunatic. God, it's just so stupid. Alright, she doesn't even understand the very basics of physics and she only wants to hurt other people. I mean, it's just so ridiculously stupid. I spent 10 years making arguments, physics arguments. I don't make arguments about hurting people, retard. Oh, goddamn. Except, maybe we should be locking up some Looney Tunes. They really shouldn't be let loose on the internet. Oh, man. Too fucking idiotic. And these are the morons I have to argue with? This is the best the internet can produce? It's just so bad. Anyway, alright, moving on. So this was a interesting summing up of, I guess I'll read this stupid Tesla comment since he posted it. No, I don't want to reply, I want the read more thing. Please don't hate on Tesla. I'm just hating on, it's not really even hating on Tesla, it's hating on the Tesla hype. Okay, the fact is he was more about theater than science, and it's just a fact. He put on shows, okay. The man invented the first AC motor. Well, I don't know, those aren't even true statements, but whatever, fine. As well as AC generation. So he didn't do any of that, so that's all just bullshit. I mean, the guy who really invented it is some European guy who, made it work, transmission lines, the whole thing, transmitted water from a hydroelectric source to, a carnival or something and all of that crap. Well before Tesla. So this, just, this is the hype. This is the part that just makes people want to say, hey, it's not the truth. So why are you over exaggerating the accomplishment? You're the problem. All right, look how more efficient an AC motor is compared to a DC one. Well, it's not really true again, okay? So it's a specific kind of AC, three-phase motor that Tesla invented. And those three-phase motors have an awful lot more to them in a sense, okay? They get rid of brushes and this and that, but they also have a lot more wire and they're a lot more complicated to build. Good example is the ceiling fan. Yeah, it's a good example of a really low torque motor. They are insanely efficient. It's not really insane, okay? It's 20%. But okay, fine. I've got fine ceiling fans, 24 hours. Well, whatever. I don't know what your thermal problems are that you have 5 ceiling fans running all the time, but whatever. Okay, that will leave to be your private business. What are you, like Jabba the Hutt or something? You can't move without, generating millions of watts of electricity, and therefore you have to, keep cooling the system. But I don't really want to know, so whatever. Who cares? I'm just saying, just all this hypey crap. I mean, there was, Tesla did 2 or 3 days of good work, and the rest of it really was just bullshit, okay? He has a bullshit understanding of reality. He tried to transmit electricity to France through some magical system, some arteries that he thought the energy blood flowed through. I don't even know how to analogize what he believed. But clearly, that part of it was just such nonsense, and he wouldn't take no for an answer. And it's and he had to do everything his way, and he just wasn't very and again, it was the age of invention, for fuck's sake. Every 3 days some new invention arose in the world. I mean, I'd say Thomas Edison is rather amazing in terms of the litany of brilliant inventions, but also you have to recognize they were all there to be invented. I mean, it was the Industrial Revolution, and all kinds of things were being discovered that could be turned into something. So, frankly, and you could certainly improve things. It was all there to be done. But whatever. All right, just annoying. Really. Okay. So this ad channel name, which is sort of a, it's not a great channel name, frankly. It doesn't matter how many times you explain this stuff logically and rationally. I don't think that's the problem. The problem is there's no audience who can be challenged. Okay, they're all wimpy, wannabe fakers. Okay, the people who are arguing. There's no people in this argument yet who really have an understanding of any physics or really did any research on anything. And all the ones who have that knowledge have clearly run away. Okay, I mean, I can't even get them to name their price. How much would it take to be a victim of their debunking? How much do I have to pay them to prove me to be irrational or wrong? And they won't take my money. They won't take my challenge. So that's the problem. That do you think there'd be some people who just happen to have a physics degree, who happen to love science? That maybe they aren't using the physics degree. Maybe they have some other kind of job, but they really, they still have a subscription to Science Magazine or something. You know what I mean? Somebody that cares about the truth and getting there and understanding reality. And you'd think one of those would show up to say, hey, this is nothing like what I was taught. It's a blah, 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 blah. But yeah, I mean, but they'd have to concede the point that, yes, they were taught it and there was no show me involved. It was just, you tell me what reality is and I'll believe you. Okay. But, so I don't think it's just as simple. The deluded will stay deluded. So I don't think that's true. I think that once the fight takes place and people are exposed to the fact that this conventional physics has no real compiled evidence, that they have a very weak argument that what they have done is not scrutinize their fundamental axioms well at all, and that they really have just created a kind of religion. Because of their self-imposed exile from the marketplace of ideas, so yeah, there is a whole bunch of people who, well, I don't even know what to say. Yes, they're too elite to be bothered. But you see this. I mean, it is unfortunate that there's disagreements in physics, but the physicists really won't show that. So it's like, I guess you could argue, you don't see too many times where Muslims argue with Christians, for some reason. Even though they have separate religions, they don't really argue it. And I guess the same kind of psychological mechanism is at work here. They will stick their fingers in their ears and sing the phrases of their heroes. So that's these knee-jerkers, obviously little bandwagon riders, okay, who just want their cotton candy, and, they don't care about anything else. They're just saying free cotton candy on that bandwagon. Anyway, the saintly figures of scientism. So I don't like that phrase at all. So that one just makes me wonder what your agenda is. What the fuck's scientism? Frankly, if I was going to be called something, I am a scientist in the sense that, yes, I think science is the way to go. Certainly all the other options suck. So yes, the scientism is a lot better than Godism. Anyway, like Einstein, Maxwell, and Huygens. So again, all of these characters had their flaws, and but Einstein wasn't afraid of the argument. It's just that nobody made a very good one. And then you say Maxwell. Maxwell did some good math, but that's all it is math, and it's not conceptually, in my opinion, well-founded. So the fact that he believed in an ether was his mistake, frankly. But anyway, and Huygens the same way. The whole wave thing. Wave in what? I don't know. I can keep asking the question, but, no one's going to give a reasonable answer in some magical field that can sense everything's motion in some way, who knows how, and responds with some counter motion thing that causes things to do this for no good reason. As they're going this way, they have to do this thing. I don't know. All right. Let's see, a question for you, Draft Science. This won't be a question. So this is Imbecillus Cilius or something. I don't know what his name is. Calcus. I don't know. He has some unpronounceable name. Some foreigner, no doubt. Anyway, if I put an object on a table, is the table constantly doing work by holding the object up? It depends on how you want to define work. It's a very slight amount of work, I guess I would argue. See, jiggling something, holding something, you're really doing this. Okay, that's work. But if, for example, all it's doing is going through your skeleton, your bones, and your bones are holding it up, it's hard to call that the same work. But in a sense, it has to be, because the real thing doing the work is the ground you're connected to. You're just a conduit between the ground and the action. So there's action up here, there's action down here, and you're just stuck in the middle, right? So, but if you're deliberately, actively moving your parts, you have to say you're doing work. So part of the work is you suspending the object. But frankly, you're always using the ground as ultimately the force that'll give you the capacity to push it. The ground has to push you up to keep you able to push the other thing up. But the point is this is happening. And the jiggling part, that's the part where it's a bunch of waste. So if you're jiggling something as you're lifting it, you can understand that's a lot more work. All right. And that's the point. So the more rigid the object, the less jiggling, you could argue, and the less work, in the sense of you having to create some other mechanism to create all that extra motion. All the ground can do is push back. The jiggling isn't its business. It doesn't care about that. So the fact that you're wobbling doesn't have anything to do with the ground pushing. But the whole definition of work is just kind of what is work? Work is what we call exchanges in motion that do something we like. That accomplish something. Yeah. But there's lots of exchanges of energy that don't have anything to do with what we call work, but they're still exchanges, and it's still motion in the environment. So things like heat and all that kind of stuff is still energy. And I guess I would say that work really should just be a word that we don't bother with, because there's just energy. Alright. There's movement. There's mass moving. And the process of making this mass move versus the mass you want to move. Again, it just has to do with, we call it work when we can follow along and see the process of going from the thing we want accomplished and the source of energy we use to accomplish it. Alright, so that's enough of that. And I guess we'll do this Huygens optics video. I didn't play it all the way through because it's really not much of a video, frankly. I mean, it's just a lot of talk with, so I suppose later on he gets to some sort of evidence, but it's probably the same evidence I've already debunked, in the sense of talked about the experiments he's describing in a way I think is just totally wrong. It's not loading, so we'll have to refresh the page. Let's see, have to do the commercial thing. Blah, 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 blah. So he has done some very sophisticated experiments, really well done experiments, but again, it's all about interpretation and recognizing what you're really seeing. Alright, so trying to find analogies between wave energy confined in a string and matter interacting with light. So
with the square of the local electromagnetic.
I don't think that's going to get you anywhere. Yeah. I mean, light's not a string. Its energy isn't in the form of bends in the string or any of that kind of crap. It really is a pulse, would be a better analogy. It's just, again, momentum. Light is momentum. Alright, charged ball from plasma channel. Insane 500,000 volts. Okay, whatever that is. Reflected wave. If you'd like the painting, then visit Renee something website. I don't know. Did I forget anybody? Let me know. Well, whatever. Who knows? So this is it's nice to have one of these little indexes, but yes, it doesn't go very far. And it ends with elastic inertial poetry. Ooh. I don't think so. I don't think I like the word poetry at all.
You know what this is, right? It's a pipe. For some people, especially men of a certain age, it's a means to exude authority. Oh, but wait, here it says it's not a pipe. It's actually a painting of a pipe. The painter added the text to confuse the viewer. So...
Oh, the painting, that's what he said, right. Well, who cares? So you want to buy the painting. Oh, very exciting.
Here's a real one. Can you smell it? I don't think so.
Oh, whatever. So, I mean, this is all, what the hell? We're going to play little word games, Physics is all hidden in some sort of little stupid word game. Ugh.
That's because this is as much a real pipe as this is one. So, whatever these are, they're certainly not pipes. You know what this is? It's an electron. An electron is a little charged ball cloud thing. Let me dazzle you by summing up its properties like mass, charge, spin states.
Right, so again, these aren't its properties. We know that, yes, it probably weighs something because it carries momentum again, so that's fine. And we know it's charged because, yeah, we can basically watch it go from one object to another object and add the charge. But this whole spin thing isn't even a real thing. You know, and the wavelength is really, you could just say, you know, you could use some other word to describe its frequency, as it has a character of having a frequency between events, period.
And why not wavelength? Yet despite all these numbers, I don't have a...
And why not wavelength? So you just threw that in, like, yes, we know light has wavelengths. And we know electrons are influenced by photons, so, but there's no reason to say electrons have a wavelength. I mean, come on.
Clue what an electron looks like, or what mass is, or charge, or spin really are.
Yeah, well, that's just, isn't that just, to say spin and mass in the same word and say we're equally confused about all of these concepts would be really silly. So obviously the concept of mass and movement aren't very abstract, so they're really kind of easy to model and to accept some axioms about. The rest of it, again, is all just kind of a religious theory.
So yes, I can just sum up properties without really knowing what they mean or what they even try to describe exactly. And so I'm just showing you this little ball as a metaphor for an electron.
Right, but you don't have to just do that, because Maxwell kind of drew it all out for you. So yes, you've got it right in the sense that you could have a red ball and a blue ball to do plus and minus. So the electron could be understood as some kind of little object in space. And the fact is that it radiates. You know, a charge, the essence of its charge is essentially a radiation that obeys the inverse square law. And you could just draw these arrows in all directions to indicate the force field that's created around the electron. And you could either understand that as being something it generates, or you could understand it as something it just reflects. But it doesn't really matter. But it's kind of well diagrammed that works. It's a very the model duplicates the reality.
Why? Well, because most people can relate to a ball, a spinning ball, a charged ball. Anyway, whatever this is, I'm pretty sure it's nothing remotely like an electron.
Yeah, so why are you pretty sure it's nothing remotely like an electron? Some idea of a very small object that has a very consistent form and shape. The electrons seem to be, every indication is that they don't have any individual personality. Whatever the spin would be or all this other crap, they really don't have these uniquely different properties.
This is a photon, at least.
So again, that drawing is way off. So the electron, you did okay. This piece of crap is just that, a piece of crap. This isn't even a thing, okay? This is a pattern. We don't even get to see the thing that's involved. This is what a thing does. You're saying the photon is doing all of this crap. So my counter argument is the photon, like the electron, is just a very discrete, simple element, particle. And all that needs to be understood is that it's not, hopefully you can see that crappy video. Yes, you can. All right. So yeah, this idea that a photon is doing this and this, you know, that it's doing that in the electric field and then it's doing the opposite, you know, perpendicularly, it's doing something in some whatever called the magnetic field, when it could simply be understood as quanta of energy, as Einstein put it, and that frequency can be understood, and each little bit moves at the same speed of light. And all you're really saying is you have these little bits in space, and that space, they can be in all kind of random ways. They can be in random positions, or they can be in organized positions where there's a very clear, period between them, a distance between them, a frequency. And you could do it with just two. By having two of them, you have a frequency. But let's just say there's three, you know, just to make photons a little more rare. So you have to do a little work in the universe to create this pattern. out of a bunch of chaos, right? You just have a bunch of chaos over here, and the fact is it doesn't have the pattern in it unless you put the pattern in it. And how does the pattern get put in it? Well, it gets put in it because electrons, the much bigger thing, okay, move here. And when it moves here, what is it doing? This stuff is going to bounce off of it. So it comes in, well, somewhat randomized and of a certain distance. And when this pushes into that, it's going to end up mashing it closer together. So I didn't really draw that perfectly. Yeah. So these are further apart. And when you push in, you confine them. And when the electron moves the opposite way out of a field, well, then the reflections are going to be wider spaced, and you're going to go from a higher frequency to a lower frequency. So you can understand that some kind of pattern can be created by creating consolidations. And so if we have a bunch of objects here, okay, and they have a certain distance from each other, and then we consolidate them, a bunch of electrons push out and consolidate, then we know that in certain areas there's going to be a high density of particles, and in certain areas there'll be a low density of particles. And the fact is you're starting to now get the idea that yes, I can create a lot of photons out of this change in the density that the electrons could be creating. Anyway, so it's just about, it's all, you can get into all kinds of the different properties, and the one he didn't mention of the properties when he was doing electrons was polarization, because photons have the polarization, and the polarization in the sense that they fly through space and they hit on a surface as an event. So photon doesn't just arrive. There isn't something called a photon that arrives. There's an event that takes place on a surface that's essentially the same as electricity. What you're really doing is pushing on atoms, and most importantly the electrons in the atom, and in a sequence of events you're going to push on one atom, and then you're going to push on another atom, and then you're going to push on another atom, and in that process you're going to keep adding energy. So you hit this one first, it produces energy in that direction, then you hit here and you produce more energy in that direction, and then you hit here and finally produce enough velocity in the electron to eject it from the atom. So as you pressurize the atoms, you hit one atom, pressurize it, it spreads the pressure to the other atoms. You hit one of those atoms that has had its pressure increased, and that means you're going to have a higher energy electron leave, and then the final one will be adding to the accumulated velocity that you've created. So the photon is a bang, bang, bang event, and with each bang you're adding a little more energy to the electron. So you could think of it as a tipping point argument or something, where you hit something and it's not enough energy. But if you hit it again, then you can add, and then you hit it again, you can add. And that's why frequency is really highly connected to the idea of a resonant frequency, a frequency where energy is added, a system where energy is added versus a system where energy is subtracted.
This is the way that it's often depicted, and that's because we assign both particle and wave properties to it. Therefore, it's often displayed as some wavy particle, some discrete intermediate between the emission and the absorption of radiation.
Right, so this is where it all kind of, like I said, falls apart, in the sense that the conversation really should be about resolving the duality, not making the duality, not trying to find rationalizations or reasons to force waves to be particles or particles to be waves, but to explain why it's not a wave or why it's not a particle. And I think I can explain why it can't and isn't a wave.
A particle of light, if you want, traveling from A to B, right? Well, I guess that's not what it is. Here it says...
Okay, yeah, it's not what it is, in the sense that there's different things you could argue are points to make to say why it isn't that. A good reason to say why it isn't that is that a radio wave could be 10 miles long. That is the frequency, the period between the size of it. Could be a mile, it could be 10 miles long. How could that be a particle? A particle can't be 10 miles long. That doesn't make any sense. So obviously, but the idea of a discrete bit ejected and then, 10 miles at the speed of light later, another bit is ejected. The idea of shooting bullets with a very, with a long delay between the bullets is perfectly understandable. The idea of shooting some bubble that is 10 miles long isn't very reasonable. And then you could argue about the size of electrons and how tiny they are. 10 to the minus 32 or whatever, some tiny thing. How could a whole photon that's a mile long possibly interact with one electron? That doesn't seem at all probable or likely or sensible. And that obviously all the, you'd have to argue that the photon has to be really affecting different electrons and or different atoms, just because of things like polarization. And the polarization is consistent with the wavelength in terms of the distance of the wavelength is related to the polarization, the shape. And clearly when it hits something, that polarization is thousands of atoms across. So how can something that has a dimension in height, of thousands of atoms hit a single electron? So, there's lots of arguments you can make why it's not really reasonable to think of the photon as an object by itself. It's a pattern. And the pattern hits a surface and causes an effect.
Photon can be described as an amount of energy and momentum.
Right, and the energy would be in the idea of the quantization. So the whole point of having quantum physics is recognizing that it comes in these clumps and that the photon is also clumpy. And that's makes sense.
Nowhere does it say that it's some kind of localized wavy particle of radiation, nor do these formulas tell you anything about a shape or a size.
Well, they do tell you something. I'm just saying the idea first is that they're a real thing, okay, because they have momentum. So saying they don't have mass would be kind of illogical and nonsensical. And you have no reason to say they have no mass. You have no reason to say they don't have a mass except your theory that somehow electrons produce them. So I guess if you think electrons can actually make a photon out of something inside of them, well, then you could say they can't have a mass because electrons don't lose mass. But if you understand that really all the photon is a field effect, that it's already in the environment. The pieces are all over the place. The energy is hitting me all the time. And it's just reflecting off the electrons. And so, but, that's stuff you can piece together. The fact that it has momentum means forget about this notion that it doesn't have a mass. It's nonsense. Of course it has a mass, and it has a velocity, the speed of light. The bits that make it up, the bits that make up what will arrive as a photon, clearly have energy. They're moving masses.
So that is what a photon is, just energy exchanged between matter and radiation or vice versa.
Matter and radiation. So let's just understand. Yeah, so that's fine. You could replace radiation with the word force, bits or force or whatever. But yeah, that's all there is. There's matter that's kind of dead, and there's the stuff that pushes it around. And I don't think there's anything that defeats that simple idea of stating that's what the nature of the universe is. There's little bits moving the speed of light, and the big bits are being pushed around by them.
So if that is what a photon really is, a much better graphics representation of it would probably be something like this. Here the arrow represents the photon being...
Right, but you still have the photon being represented as a one thing when it's really just the byproduct of an event. Again, it's an event. It isn't It lands as an event. It's, like I said, every way we detect one is through an event, electricity. These are events. They're not, yeah, it's an event. It's more than one action makes a photon.
Transferred from matter to radiation. The photon isn't the radiation per se, it's the energy put into the radiation.
Alright, so this drawing has the electron producing some sort of energy that somehow produces some sort of thingy that's doing this, whatever, this jiggling in some sort of medium thing, this field of whatever. When, no, the simple argument is that energy comes into an electron and the energy is excreted by the electron, and the change in that pattern created is what we call a photon.
Likewise, when energy is absorbed from a field by an atom, the term photon would refer to the energy transferred from radiation to matter. And if you think about this a bit more...
Yeah, whatever. So I just don't think there's anything elemental in this, so there's no thinking about it anymore, because you're not saying anything about what a photon is in terms of just being kernels of energy.
Or the photon being emitted and the photon being absorbed can be unrelated to each other, because the total field in the absorption...
So we know the only way it's absorbed is because it gave its energy to the electron. So that's how it's absorbed. And everything else is just a reflection. So the only absorption is through the motion of an electron. Changing the motion of an electron
can be the result of many photon emissions. And so the photon in the absorption is probably not even the same energy. So whatever this is here, we can safely say that it's definitely not a good depiction of a...
Well, whatever. Yes, this is not a good depiction. But he's going to defend a wave theory in the end. So what's the point of saying this is not a good depiction? When, and again, he's got Planck's constant times V. And well, Planck's constant could just be argued to be the mass of the force.
Photon.
The bits.
If you've seen the previous two videos I made about coherence and light, you'll know that I personally like to focus on the wave.
Right, and I argued and countered both of those without any response from him.
Properties of light. And that's because I'm working in optics, and so I'm almost exclusively in the business of manipulating light in the visible wavelength range. Almost any phenomenon that I encounter in optics can be explained by assuming that light is just an electromagnetic wave.
Whatever that would mean. It's just an electromagnetic wave, which doesn't say anything. So again, he's got the typical two-slit interference nonsense drawing here. That doesn't have anything to do with reality, because we know the single slit does this pattern, and there's no wave correlation. There's no explanation for why a single slit would produce two waves that interfere with each other, except in understanding the surfaces are the sources. And that's why there's two sources in the single slit, and they're really not doing any wave construction, destruction. They're not interfering with each other in the space. They're basically just landing on a surface, and they're either in phase, that is, their frequency is correct, or their frequency is broken. And that's the rational explanation.
Refraction, that's just a wave going from one medium to another medium where it has a different propagation speed.
So again, it's not just about the speed of propagation. It's obviously about how you push the electron. And so you're going to be giving energy without giving energy in a direct into the surface direction. So you're hitting a surface at an angle, which means you're pushing the electron not in, but almost out. On a pressurized surface, pushing sideways is almost the same as saying you're going to be pushing something out. So you're not pushing in directly. So it's just about the fact that the force isn't being put in directly. And that's why you get these angles of reflection. But they're just really reflections.
Refraction, just waves bouncing off surfaces. Interference, just a linear superposition of waves. And in fact, all
there's no linear superposition of waves. So again, that theory doesn't work. The Huygens drawing of the double slit is really a drawing of a single slit pattern. So it really doesn't have any continuity or have anything to do with reality, frankly.
These basic principles for the manipulation of light work in exactly the same way at any intensity level. So, from the perspective of classical optics and the way that light can be manipulated as a wave, thinking in terms of photons is completely unnecessary. So why are we constantly referring to photons when we talk about electromagnetic radiation? Well, as I just illustrated...
Well, that's because it started off that way. That it started off with this idea of a wave versus a particle, and in both cases the idea was somehow that there was a blob, okay, there was a photon, and that the photon wasn't really just a pattern. Now, even when you drew it as a wave, you just make up how many waves you put in the wave, right? You just tell me, well, the wave is 17 of those things, or 500 of those things. You don't put any time limit on how much wave actually has to hit the surface. Does just one of those lumps have to hit the surface and I have a photon, or is it 17 or 150 or 600 million? You never described any of that. No one ever did, and none of you were curious enough to say, well, what do you mean by photon? How is there 7 photons there? Are there 10 photons there? How many photons are in that drawing? Am I keep hitting the surface with a continuous amount of this jiggling stuff, and it doesn't matter how much jiggling stuff I hit it, it's just one photon? I mean, it doesn't make any sense.
In order to detect this radiation, we need something to interact with it, like electrons. And when you study the interaction between radiation and matter, you'll find that it is quantized in nature, that not just any random amount of energy is being transferred, but discrete and well-defined amounts of energy. And what we also...
So that would be related to the fact that, first, frequency. Obviously, you can fit more bits in the same space, the higher the frequency. The higher the frequency, the more bits of matter, so that would be an obvious indication of more mass. More bits means more mass, means more photon. And the velocity is always a constant, so that could just be placed as some other word, because that's not a variable. In a sense, you have two constants there, right? Planck's constant and the velocity, which is also going to be a constant. So it doesn't make much sense, because you can sort of say that, yes, the energy level of photons changes based on the frequency, and the frequency is really just about the amount of movement something's going to have. And obviously, the more you hit something, the faster you say, if I do want to tip something over, I'm more likely to be able to tip almost anything over the faster I hit it. So if I hit it, I'm just saying, the slower I hit it, the more chance there is it comes back. The faster I hit it, the less chance there's anything coming back. I'm never going to be going against the motion. The motion's always just going to be adding. So the faster I go, I guarantee that each bullet, say, that hits the surface will hit the surface when it's moving in the right direction. See, the idea is the bullet's going the speed of light. The thing is not going to move that fast. It's going to go 1/10 the speed of light. So if I hit it with a bullet going the speed of light, now it's going 1/10 the speed of light. Well, the fact is, the next bullet's going to come much quicker than the rebound speed of the object, and so I'm just going to keep pushing it. I'm going to keep increasing its velocity. I'm going to keep adding energy. And so high frequency photons are more guaranteed to keep pushing something and adding velocity, where lower frequency, there's a real chance the electron starts moving back to its original position. It starts going the wrong way.
Find is that these amounts are always linear with the frequency of the radiation involved. And for the light in the visible wavelength range, the quantized nature of the interaction becomes especially apparent at very low radiative intensities, because in that case the transfer of energy only occurs occasionally. Now the question that I have...
So this has to do with the photoelectric effect. So, and he didn't say that, but that's what he's talking about. So he's talking about the fact that at a certain low frequency light, I do have this problem that the bubbling surface of electrons is able to stabilize because I'm not hitting it with high enough frequency light. So every time I hit an electron, it starts to go back before the next bit might put more pressure on that electron. So I can't maintain any pressure because they all rebound. Okay, so I'm not hitting it fast enough to stop the system from rebounding. But if I hit it with the ultraviolet light, then I guarantee that I'm always going to add energy to the electrons, because I'm going to keep applying a pressure that's higher than the surface pressure. And so I'm going to keep adding velocity to the electrons, because the rebound pressure won't negate what I did. I won't jiggle. I'll actually move. So it's the difference between just jiggling something and then causing it to move.
And you might have as well is whether the observed quantization in the interaction really proves that radiation is quantized, that all electromagnetic radiation itself consists of discrete packages of energy, or that alternatively...
Yes, the real problem is that we are going to detect photons with a clump detector. We're going to collect them with essentially something that's detecting the ionization of an atom. We're detecting a big object on electron motion and calling that a photon. Okay, so we get an electron to a certain speed, we call that a photon. Electricity is the photon. And the fact is that the energy that created the photon is made of much more discrete, smaller bits. And some of the things hitting it are still energy. We just don't call them photons.
The quantization we observe is merely the result of how the interaction works. And since there is no way to detect radiation without interacting with it, it's difficult to distinguish between energy quantization being a property of light, a property of matter, or a property that...
So it wouldn't change the quantization argument. It doesn't disprove quanta to argue, okay, that we just have clump detectors. So the fact that we just have clump detectors doesn't mean it isn't clumps. But yeah, it does mean that you can't rule out the fact that your clump detector is really detecting a wave and you're just seeing it as a clump. But it doesn't make waves more valid as an explanation. And there's lots of other reasons to recognize why waves don't work. Yeah, waves in what?
Emerges from the interaction between the two. The thing is, if you consider a photon to be a particle of light traveling from A to B, then all experiments involving light interference...
Alright, so this is the big fake. So again, he's done all these complex experiments and he's doing the typical bullshit of we're going to pretend, okay, that this geometry works, that the going through the center of an opening somehow creates a deflection, when that's not what the evidence really indicates. The evidence indicates in the single slit that it has to be the surfaces. The surfaces are explicitly in the math. That's the sources are the surfaces. And that all of these deflections are taking place from the surfaces. The surfaces are the source of all the fringe light. I mean, it's just, undeniable that that's the first suspect, because the single slit sort of proves it, because it's what the water waves don't do.
As for example observed in the double slit experiment.
So this isn't the double slit pattern. This isn't the, this is the single slit pattern here. Double maxima, hump, 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 and we can have 70 of these things, and they make it look like it all runs out of energy and it's very weak and all of that crap. And all of that crap is just that. It's crap. It's not the truth. It's nothing like the truth. It's nothing like the pattern. So the idea that I can have a blob of light, a blob of light, blah, I mean, I can have a real pattern here. 70, 80, 100. You can make 100 little on-off bit patterns by having the slits wide enough. So if you have the slit wide enough and you do the experiment, you can create a lot of these little on-off pattern. It's not just one big blob and then two little ones on the side and that's it. That's the end of the interference pattern. So this is just such a fake drawing. And again, it's not the double slit pattern. You're just showing a single slit pattern here. So this is some idea of using infinitesimally small slit openings and therefore essentially turning 2-point sources into a single point source. So if I put 2 points too close together, they're going to look from space like 1 point. I can't make a wavelength of difference between these 2 points if they're right next to each other. But if I separate them, well, then I can have a wavelength of difference between them at different points. And the further I separate them, the more wavelengths of difference there can be at more places in space. That logic just completely unravels all notion of wave interference. It's completely unnecessary.
Don't make much sense. But if you consider the photon to be the discrete and probabilistic transfer of energy...
So again, he's just using more really crude fake drawings. First, that there's any round waves going in, we use laser beams, very straight waves, so that's all bullshit. And then that there's two round waves coming out of the surface. That isn't what's happening. It's all coming off the surfaces. And in the double slit, unless these slits are, if these slits are more than a few wavelengths open, which is a tiny, amount of distance, you're going to get an envelope pattern here. You're going to get two patterns superimposed on each other. And the two patterns are going to be created because you have four sources, not just two. But if you make the two sources, two of the surfaces really close to each other, well, yeah, then you only have one source, because those two surfaces don't create the math. The distance between the two surfaces is too small, and you won't be able to create a wavelength of difference, so there won't be any phase change. And you only have a phase change when you have enough distance between the two sources. Then you can change the phase.
Between radiation and matter, things suddenly become pretty trivial. In that case, the probability of something happening is linearly proportional to the intensity, or if you want, with the square of the local electromagnetic field strength.
So there's nothing probabilistic about any of this stuff. It's real hard physics. Real little bits are going to hit real surfaces. They're going to be deflected real amounts based on whether the electron is going in or going out of the surface. And the fact is you're going to have a real deflection, and you're going to have a real end product of a thing going a place. And likewise, the other surface is doing the same thing, and the other surfaces are deflecting photons, and they're both doing it, in a randomized way. And the fact is, on the surface, you have a 50-50 chance that you've put a photon back in phase, that you've put the energy back in phase.
And so, the process is just more likely to occur where the field is high. In this view, the photon, the quantization, and the probability of energy transfer are just consequences of how light interacts with matter, and they're not a fundamental property of radiation itself.
So I don't even know how you could even say that. It's not a fundamental property of radiation itself. I don't even know what that means. I mean, clearly the pattern is in the radiation, and the pattern causes the electron to behave in a very specifically different way than without the pattern. That would be the simple, I think, way to describe it. The pattern makes the difference, and the pattern is in the field energy, not a controlling field, just the circumstance of there being energy in the field.
In this video, I want to see if we can gain a bit more understanding about wave behavior and the relationship to energy. This video is not a scientific study. It's just intended to tickle the imagination of a few nerdy brains and to maybe present insights from a slightly different angle. I'm not
right, so it's just propaganda for, frankly, his point of view, and he'll just call it something else instead. Fun, no. So he's going to isolate and focus on, where again the focus can be, the controlling focus is, another word for agenda. So the point is that each experiment is valuable, and it's just about trying to pull out of the experiment what the real result indicates, what it's really saying versus what you might want it to say.
Not claiming to present the truth here, so feel free to disagree on any aspect. I'd like to start off.
He says feel free to disagree, but he won't respond to any of the disagreements, so it doesn't make much difference. So feel free to counter-argue in a way where I will never respond to anything you say. Yeah.
By showing you a few experiments using the most basic representation of a wave. A one-dimensional linear wave in an elastic string. The waves we generate are transverse waves, which means that the displacement or amplitude of the wave is perpendicular to the direction of wave propagation. Another type of wave is the longitudinal wave, where amplitude and wave propagation are parallel.
Right, and these are all in mediums, where either atoms are being forced, pushed into each other, or they're actually attached or attracted to each other. So it's just about basically jiggering atoms that are, so it's about basically manipulating magnetically or charged controlled objects and how you can vibrate the charge. So this is about vibrating things, mediums. This isn't really about what's the nature of a photon. None of these. This is again trying to do the, let's compare it to water, let's compare it to sound, let's compare it to sound in material objects. It's just, it's not a it's not parallel. These things are not analogies for each other.
And the latter type is, for example, found in the case of sound waves. Now, the experimental setup is not complex, and I actually built it on the kitchen table. So to create the waves in the string, I used a modified speaker cone that is connected to an audio amplifier, and that amplifier in turn gets its harmonic signal input from a function generator. And here you can see that I glued a plastic pillar in the speaker cone to which a string can be attached. I thought I'd start out by showing you how waves are introduced by displacement of the cone and how they then propagate along the string. In this example, I left the string a bit longer and connected the far side to the kitchen sink. A single wave pulse is introduced in the string, and you can observe how the wave propagates through the string to the other side. Here it reflects back and then travels in the opposite direction, where it also reflects again on the speaker. And this process is repeated until the friction with the air and the elastic material has dissipated all the wave energy.
You always understand, it's dissipated it because it's had to move actual weight. It's had to move atoms of atmosphere. So if you get rid of the atmosphere, that would be a big help. And then the other part is it's stressing the actual material. So every time it pushes the material, some of those atoms actually tear. And so you need energy to put them back together to, fix the tears you're making. Little tiny tears that'll be waste energy.
The movement of the speaker cone displaces the string and thereby gives the string kinetic energy in the transverse direction. But at the same time it also stretches.
So whatever kinetic energy means here, so no, it gives it momentum. So it moves the piece of paper. It moves it from one place to another place. So it's all its atoms have to agree to go to the new place. They all have to be energized in that direction, pushed, frankly.
Stretches and compresses it in the longitudinal direction, and this creates a longitudinal wave in the material, a sound wave if you want, which actually moves faster through the string than the transverse wave can. If you've watched...
Well, okay, so there he's pointing out that what you're really doing is disturbing the material. Some of the material is going to lag behind the disturbance, and some of the material, the energy will be in two forms. The effect, which will be lagging behind the cause.
Carefully, you might even have spotted the effects of the longitudinal wave in the previous images. Next step in the experiment is limiting the length of the string to a smaller, well-defined region. And if we generate waves on one side, they are reflected on the other side and can bounce around for some time, same as we saw before. Using a continuous oscillation, we can in principle introduce waves of any frequency into the string.
Right, so now we're going to get into the resonant frequency, which is really just saying they're in phase. So you can have little blobs of a photon that are 5 miles apart, and then you could have blobs that are 2.5 miles apart, and they would have a parallel in the sense that they would still be adding to the system. And you can keep doing things like that until you reduce the amount of any energy hitting something when it's not moving in the direction you want to add the energy in. So it just depends on what the reflective rate is. What's the minimum amount of time something needs to bounce back. And once you've eliminated that, every frequency is a resonant frequency above that frequency.
But with some frequencies we observe a special condition in which a standing wave forms in the string, and when this happens the string resonates and the transverse amplitudes observed suddenly become much higher. The standing wave in the string with the lowest frequency is observed at around 8 Hz, which holds just one antinote.
So the weird thing is that these experiments have been done about a zillion times. They've done this with gas flames. They've done this with so many different mechanisms. I don't know why this needs to be redone, frankly.
If we increase the frequency of the signal injected into the string, we can observe several standing wave conditions, all occurring at multiples of 8 Hz. And between these specific resonance frequencies, you'll generally observe that the string moves in some irregular way. So creating standing waves is all about introducing exactly the right value for the oscillation frequency. Now,
Right, so it's just the drawing of what I just said, basically. So these resonant ones will all be additive, and anything off of those will end up causing a reflection that'll be opposing the energy coming in, and they'll sort of cancel each other.
Show you a few aspects of standing waves. First, how they're formed, starting from a string at rest. In this image you see the same string multiple times. Now watch what happens when standing waves with various resonance frequencies are introduced in the string. This is slow motion footage recorded with a smartphone, so it's not very detailed. But if we look at the startup again, it's clear that it takes some time for the standing waves to build up and reach a maximum amplitude. And during that time, the waves are basically accumulating energy. Energy that's constantly supplied in phase with the wave energy already present. This buildup of energy continues until at some point the loss of energy, for example due to friction, reaches an equilibrium with the power that we put in.
Right, so you start minimizing how much you're losing. So you're losing a lot when you're starting off because you have a lot of noise and you haven't gotten the right frequencies that are all on the same speed. So it's like takes a while before you get the noise out of the system.
Let me show you what happens if we stop the energy input for all these standing waves. We observe that the amplitudes go down fairly rapidly due to the effects of friction, with the highest frequencies going down more quickly. But notice that the number of antinodes remains the same during the decay in all cases. We do not, for example, observe transitions in the string where the number of antinodes suddenly changes. And so, if there were no friction and no influences from the outside, these wave modes would basically be stable forever. Let's for a moment consider how energy...
So it starts up noisy, it finishes quiet. So it stays in phase, it just loses energy. So you construct you make it coherent, and it stays coherent as the energy leaks out. But putting the energy in, you have to go from 10 to 12 to 11 to, you're going through a whole bunch of other hertz as you're vibrating it, and all of those negative frequencies you injected have to decay before you'll be coherent. But once you're coherent, once you've cleaned it of all those, the ones on resident will persevere.
Energy is distributed in this system. Here you see the shape of the string at different times during the harmonic cycle of the standing wave. The oscillation we observe is basically the result of two different types of energy at play. First, there is the kinetic energy, which is contained in the velocity at which the mass of the string moves. So it's basically present as momentum. Second, there is potential energy, which is contained in the elongation of the string. Now, kinetic energy is easy to spot. It's basically the movement that we observe. It has the highest value when the string is flat, and it's zero when the string has reached maximum amplitude. And so kinetic energy is found in the antinodes and in principle has zero value in the nodes.
So it doesn't mean anything, okay, using this kinetic energy word. This is all momentum, it's all atoms moving in directions at velocities, and so no point in injecting the word kinetic.
Potential energy is a bit trickier, but for a pure transverse standing wave, the highest energy density is found where the stretch in the string is largest, meaning that most potential energy is stored in or closely around the nodes. And so, in a
So, I mean, he's just going with the stretch of the material, the elasticity of it, so it's a rubber band and it's going to try to reshape to its original shape. And that's one form of stored pressure, but then you'd also have to include gravity, because obviously you're throwing things into gravity and then gravity's pushing them back down.
standing wave, the energy is constantly converted back and forth from potential energy stored in the elastic material to kinetic energy present as mass in motion. Now, one of the questions I had myself was the following. How does a
So it's all mass in motion. So there's no point in saying mass in motion because it's all mass in motion, and the motion really is up and down for the little bits of atoms. And the idea of there being energy, that's really just in the form of the stretch of the material. Moving, the horizontal movement of the energy is really in the stretch of the material, and the vertical up and down is it's made out of the same thing, but that's the real direction you've caused. You've caused something to go up and down. That's how you're making the waves. You're using up and down motion, and it's just the fact that in the elastic material that's going to force the action to migrate through the material sideways.
string handle the switching between different standing wave modes? For example, if a string is in a state with 3 notes and we suddenly introduce a frequency that would require a stable wave of 2 notes, how does the wave in the string deal with this change and then convert into the new wave mode? Because a linear superposition of the start and end situation is not a standing wave, right? Just look at how both the potential and kinetic energy are very unevenly distributed over the length of the string. So how does the transition between standing wave states work in practice? Well, let's find out. Here I created a transition going from 4 to 3 antinodes. Now, that happened pretty quickly, so let's take a look at that again in a little more detail. In the time between the 2 modes, we observe some kind of additional oscillation.
So he's going to in some way relate this to how a photon functions, and again, it's really not going to have anything to do with it because we know that what you're really affecting isn't an elastic band, suspended across a point. That's not what a photon is. A photon is what he said it is. It's the interaction between the force and an electron. It's the electron that's stuck in the elastic condition. It's the electron that's part of an atom, and it's already part of a charged mechanism of attraction and repulsion. It's in a state that has the elastic properties.
Along the string from one side to the other for a couple of cycles. And here you see the same experiment with 5 to 4 antinodes, and you observe something similar. So apparently the energy redistribution during the transition also involves some kind of oscillation. Now let's see if we can measure what the frequency of this oscillation is. The easiest way to listen in on the oscillation in a string is to add an additional speaker on the other side. Speakers can of course generate sound waves, but they can also serve as a microphone, because when we move the cone, the coil inside generates a voltage signal across the leads. And so with a second speaker in the longitudinal direction, we can listen in on the potential energy variations, because in this orientation, the potential energy component in the string is harmonically pulling on the cone of speaker B. If we use an oscilloscope to compare the signal from speaker B with respect to the transverse oscillation introduced by speaker A, we measure that the potential energy variations have 2 times the frequency of the injected kinetic energy wave, which is to be expected based on the energy distribution in a string of a standing wave that I showed previously. Now let's measure what happens if we change the frequency from one standing wave mode to the other. Here you see the scope image on a somewhat longer timescale, and at this point in time the frequency is switched, and in the potential energy graph at the end of the string we observe some additional harmonic oscillation. If we look a bit closer at the nature of these low frequency oscillations, we observe that it's actually very similar to amplitude modulation. And if we measure the frequency of the modulation in the signal, it always turns out to be the difference in frequency between the 2 transverse frequencies that we switch between. Now this difference between 2 frequencies is generally called a beat frequency. And if we study this a bit closer, we can relate the value of the observed beat frequency to the energy wave that we just saw running through the string from left to right.
So again, I really don't know what value this has. This is all in textbooks already, beats and all of this, the group functions and all that kind of crap. And, it's interesting, I suppose, if somebody wants to, wallow in it. But it really just has to do with whether you're going to add energy or subtract energy.
Now, why did I want to show you all this? Well, that's because there are several analogies between standing waves in a string and the way that, for example, an electron behaves when confined in space. I know comparing the behavior of a macroscopic string with something as elementary as an electron is tricky, to say the least.
Yeah, it's pointless. I mean, frankly, it just misleads people, in my opinion. These are not comparable beyond the fact that they're both, you could say, elastic. And you could say these are general rules for objects that are in elastic circumstances, and elastic meaning that they're under a confinement, and any motion is likely to get a counter motion. They're going to restore to their previous condition. So if you hit them, there's a mechanism that's going to force a restoration.
For one, because a string can basically have any energy at a specific frequency, which is not the case in the electron. But I think that we can sometimes still learn a lot from an analogy, even though it's not 100% correct.
When we were a motorized bicycle company, they said, you'll never be more than that. What will they say next? Honda, the power of dreams.
Yeah, well, I'm going
Want to know what's
buy
absurd?
a helicopter. I don't
Taco
think
Tuesday is
so.
trademarked.
You're selling helicopters.
Fortunately, someone's going to do something.
I'm going to go buy a
The
helicopter.
wave-like properties of elementary particles, especially of electrons, have been demonstrated in various experiments. For example,
Okay, so he says you. Again, you haven't demonstrated that. You've demonstrated how you can interpret results and pervert them and do all this other crap and tell me this is the same as the two-slit experiment when it's not. And yeah, so you could just do a lot of simplifications that aren't accurate. Why does this captioning always turn back on?
in the double-slit experiment for single electrons, where we
So yes, where we don't really have a double slit, and we really are controlling where the electrons are going, and it really doesn't have anything to do with the double slit experiment in light.
observe that the wavelength of the electrons is dependent on their momentum. Simply put,
Yeah, the whatever, more nonsense about some sort of wavelength that it doesn't have. It has a momentum. Okay, there's no wavelength.
dependent on their velocity, given they have mass. Now, the reason we can measure the
There's no in phase, out of phase problem for electrons.
wavelength of the electrons relatively easily is that their mass is very small, and so the resulting wavelength is relatively long compared to that of heavier particles. But the electron is not the type of wave that we're familiar with. If the momentum, so the velocity of the electron, increases, its wavelength becomes shorter. But this would also mean that the wavelength of the electron must go to infinity if the velocity goes down to zero. It's quite weird actually if you take
Yeah, right. It's quite stupid actually that we'd bother with this stupid crap where you have an infinity and then you'll just get rid of the infinity with some Lorentz contraction bullshit and blah 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 blah. It's just bullshit.
this relationship literally. So a better way to look at this is to state that the electron is governed by some intrinsic uncertainty between position and momentum. Let's assume that the total energy of the electron is contained.
So no reason to do this bullshit of pretending the electron isn't a real thing and it doesn't behave in a real way, and that yes, if you look at 1,000,000 of them, you'll have some sort of average behavior because some are going this way and some are going that way and some are going in all kinds of directions, blah 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 blah.
In some sort of local spatial oscillation, and that this energy of oscillation is directly related to its frequency. Then increasing the momentum of the electron significantly will require an increase in frequency and therefore lead to a more confined wave. So I guess the uncertainty
So, I mean, obviously when something's moving faster, it hits you over a shorter period of time. So, I mean, you could almost say, duh, right? I mean, this battery moves across the camera at a certain speed, right? The faster I move it, okay, the less time it's in front of the camera. So the same thing's happening with the surface you're interacting with. The faster you're going, the more quickly, the less distance you interact with in terms of exposing it to your momentum. So more of your momentum is released much quicker. Your momentum transfers from you to the other object much quicker. But this is just mush. Electrons are not this crap.
The relationship is not so much about the exact values of the momentum and the position, but how these properties relate to each other in a wave-like entity when you change either one of them. And this is actually fundamental to wave systems like the electron and sets limits to what we can know about a certain combination of its properties.
Wave systems like the electron. So again, he's just making the argument. So again, that's the agenda, is to make you think this wave crap, this Diracian wave nonsense has something to do with reality, when it really is not necessary to believe any of this crap. The electron is stuck in tension inside of an atom. It's attracted to the positive nucleus and it's repelled by the other electrons. Now there are electrons in the nucleus actually that are also repelling it, but it's a net positive. But it really depends on position. So from one point of view, the nucleus will look positive. From another point of view, it'll look negative. So it's all about positions.
Now, since the electron has wavelength, it must also have frequency, right? And so a reasonable question to ask might be, what is the true nature of the oscillation?
So these words are, why should we have all these different words for the same thing? Period, wavelength, frequency. It's all one thing. It should just be one word. I mean, yes, obviously if it has a wavelength, it has to have a frequency, yes.
The electron. What is oscillating and how? Because in order to maintain an oscillation, there must at least be two types of energy involved, similar to the potential and kinetic energy that we saw at play in the string. Regardless of the exact nature.
No, it's not two kinds of energy. Again, if I throw a battery up against gravity, okay, there's not two kinds of energy. There's just the fact that I've pushed the battery against a pushing down force. I've pushed up. The force is pushing down. The battery will reach its apex and then it'll fall down. It's going to reestablish its previous condition unless I establish some other reason for it not to. So it's in a system that's forcing there to be a state of equilibrium, and all you're really doing is disturbing the equilibrium, and there's a mechanism to restore the equilibrium.
Of the oscillation, the main thing that I'd like to point out is the following. Given the wave properties of the electron, it's possible to calculate how the wave of the electron having a certain amount of energy or frequency would behave when confined in space. For example, because it's bound to the nucleus of an atom by electrostatic forces. And the simplest atomic system for which this is the case is the hydrogen atom. So let's take a quick look at this system.
So let's understand that the hydrogen atom can be in a lot of states. Hydrogen 1, 2, and 3, or deuterium, something other, whatever they call these things. But hydrogen doesn't molecularly hang out as hydrogen 1. It hangs out as hydrogen 2, which is you could almost understand as it's almost like a man-woman thing. Okay, the hydrogen is just an electron and a proton. But if I put another electron and proton, polarly opposite, you could understand that that mechanism would have the right arrangement, where the things that repel each other are the furthest away they can be, and the things that attract each other are the closest they can be. And it creates something quite different than just a single hydrogen atom.
The hydrogen atom consists of just one electron and one proton. Both the proton and the electron have mass, and they both have wave properties. However, the wave properties are most apparent in the electron, since it's about 1800 times lighter than the proton. And the attractive forces resulting from their opposite charge keep the electron and the proton together. Because of the much higher mass of the proton, it's basically the center of mass, and the spatial confinement of the electron is governed by the attraction.
So let's understand, though, is all these experiments aren't going to be on single hydrogen 1 atoms. They're going to be experiments on hydrogen 2 molecules.
To the proton. Now, given the wave properties of the electron and the electrostatic confinement of the wave, it's possible to calculate which standing waves of the electron would be stable inside the hydrogen atom. And the result of this calculation is a list of various possible wave states or wave functions, each of which describes the electron having a specific...
So basically all just bullshit, okay, that the electron is in all these different positions or some kind of crap like that. It's clearly more probable to be in certain circumstances based on how much energy you put in, where it can deflect to, and all that kind of stuff. But the fact is, you're just saying, yes, it's elastic. It's stuck in a position in space, and if you hit it hard enough, you'll knock it out of that position. And if you don't hit it hard enough, it'll go back to its original state. So it's elastic.
Specific frequency and energy state. If we put low pressure hydrogen gas in a tube and then excite the molecules inside the tube, for example by running a current through it, we observe the emission of light at all kinds of very distinct wavelengths. A few of these are in the visible range, but there are many other frequencies emitted in the infrared and in the UV range. Now, it turns out that each of these emission frequencies can be traced back to a transition between two specific energy states of the electron.
And the energy states are just really talking about how close the electrons are to the proton, or how big or small the atom actually is. And so you're just talking about expanding and contracting the size of the atom.
Apart from emitting specific frequencies of radiation, atomic hydrogen also selectively absorbs specific frequencies of light. And if you look at the emission and absorption spectra, you see that these processes involve exactly the same frequencies and atomic energy transitions.
Right, so you're just saying you're putting energy in at different frequencies, and some are resident, that is, some frequencies are highly probable to cause an effect of electricity, however you want to describe it, and the other frequencies are not, because they don't push through the same timing. You're hitting a row of atoms, and the idea is it has to have the right timing. That is, the speed from getting from one atom to the next atom. The electron pressure has to move through that material at the speed of light, essentially. Okay, the speed the electrons are moving, and the electrons aren't moving a perfectly straight path. They're moving a path that's around the nucleus of their individual atoms. So there's a time that takes, and you're just saying these are the resident frequencies that will add energy and cause emission.
Now, when I did the experiment with the string involving a beat frequency and noticed this kinetic and potential energy wave running around the confinement, I got the following idea. Could this be an analogy or metaphor for what happens with the electron when it switches to a lower energy state and emits radiation? If the presence of the electron and its energy is described by a standing wave, then going to another energy would also require the redistribution of the electron.
Look, so you don't need to believe in all of this crap of waves to understand frequencies, and frequencies have resonance. So again, I could just make the tipping point argument and say it shows you how a resonant system works. So I could have some system that's elastic. That is, because of gravity, the system is elastic, and I can put energy in. And the idea is if I put it in a rate where it's always hitting when it's talking instead of ticking, tick tock, tick tock. I always hit talk. I always put it in talk, talk, talk. I'm going to expand my amplitude. If I put it in against the tick, then I'm not going to increase the energy of the system. I'm going to decrease the energy of the system. So you can have resonance without any need to create anything called a wave.
In space, including its charge. Making the electron change from one frequency to another would also involve an oscillation, because any intermediate state between the two states is not a stable standing wave, but a spatial oscillation at the beat frequency. So, in the case of the electron, this dragging around of charge in space would...
So you can understand that if I did make a molecular hydrogen 2, and if I did vibrate an electron, or pushed it, you could understand it would push on the other electrons. And it would push on them in two different ways, right? It can push on them diagonally, or it can push on them going around the circumference. So you can have these different ways of understanding how you're storing the energy in an elastic way, and the energy is taking its time to move through the object, and the time is dependent on how we keep pushing it in. And if this electron's in the wrong position when you're pushing it in, then it's not going to be able to go in the right direction to add energy. It's going to subtract energy. So you can create noise in the hydrogen 2 because you can have lots of different motions between the different charges.
Would result in the generation of electromagnetic radiation at the beat frequency. One of the key aspects at the basis of quantum mechanics is the discovery that energy and frequency are always directly related by a constant.
Right, well, whatever. This whole idea of just assuming, okay, that somehow frequency is the energy, when no, frequency is basically telling you how many bits and how fast do the bits interact with the substance. And so it seems obvious that things that have more little bits and things that have more little bits closer together are going to be able to do more work.
The constant is called Planck's constant, named after Max Planck, who first proposed it. Now personally, I look at the nature of this relationship in the following way. If energy is always directly related to a specific frequency, then differences in energy must also relate to a difference in frequency. And so effectively this means that any system that only knows discrete energy levels or wave states can only exchange energy with a specific frequency. And this frequency, ladies and gentlemen, is the beat frequency. Now, if you look at it from this perspective, then the quantization of radiation, aka the photon, is really not a property of radiation. It's a direct result of how confined standing wave systems, like for example an electron, deal with changing their energy states.
Yeah, I mean, so there's a little tiny grain of sensible conversation here in the sense that we're seeing photons based on how they are affecting electrons. We're not seeing photons. We're seeing effects on electrons. And electrons aren't, we can't isolate electrons from matter. And so we have no way to really study an electron outside of studying it in the context of it being controlled by some material object in terms of its position and its existence.
Now I guess that showing the presence of a beat frequency between two standing waves in a string is mostly an illustration for the case of the emission of radiation. The analogy being that the radiation is the result of the redistribution of the electron and its corresponding charge at the beat frequency. But what about an analogy for the absorption of radiation? From the emission and absorption spectra of hydrogen, we've seen that in the standing wave states of the electron, energy transfer with the beat frequency also works the other way. So is it maybe possible to find an analogy?
So it'd be really simple if everything was just, if the separation between those frequencies was twice the frequency and, if it matched a harmonic system. But it doesn't match harmonically, and that's what I'm arguing is it doesn't match because the hydrogen atom is more than just an electron and a proton. It's electrons and protons close to each other in a more complex molecule. And that more complex molecule can vibrate at lots of different, in different ways.
That involves a beat
in more than one way.
Frequency to make a string switch standing wave modes.
It's elastic in more than one direction. So that's why it doesn't come out 1, 2, 4, 8. Yeah.
Well, it turns out that achieving this in a string is actually far from trivial. Say we have a transverse standing wave frequency of 32 Hz and we want to transform it to a standing wave of 40 Hz. How would we do that in practice using a wave with a frequency of only 8 Hz? You cannot achieve this by superimposing transverse energy of 8 Hz onto a standing wave of 32 Hz, because superimposing transverse waves with frequencies of 8 and 32 Hz will just create a complex wave containing a beat frequency of 24 Hz, the difference between 32 and 8 Hz. Which is not what we want, because we want to end up with a stable standing wave of 40 Hz. Now, I tried a lot of things to make this happen, and at some point I realized that I should actually try to manipulate the phase of the waves in the string, because it's phase differences that relate the two original frequencies with the beat frequency. And the easiest way I saw for doing this is to fiddle around with one specific type of energy, in this case potential energy. So instead of listening in on the potential energy with the second speaker, I tried modifying phase with it by means of modifying the potential energy at the end of the string. So in practice, for the example I just gave, I would create a 32 Hz transverse standing wave using speaker A, then stop the energy feed and let the wave run free, and then inject an 8 Hz longitudinal wave to make it switch mode. So did I get this to work? Well, the answer is no. And the main reason it didn't work was because of friction. Basically, the standing wave was long gone before I could introduce any significant effect with the beat frequency. But that said, I did find that it was possible to redistribute energy in the string just using the injection of potential energy with specific frequencies and make the string switch modes. So the first one who knows how that would work and puts it into a comment below wins a pipe, a real one. Now, because friction was the limiting factor in the experiment, I built a vacuum confinement for the setup. And the vacuum tube I made could easily be evacuated to below 20 millibars, thereby, in theory, reducing the friction with air by a factor of more than 50. However, when I measured the actual effect of the vacuum on the lifetime of transverse oscillations, the result turned out to be very disappointing. Here I measured how standing waves fade in the case of both air and vacuum. You observe that instead of 100 millisecond decay time in air, it's now 200 milliseconds in vacuum. So only a factor of 2 and not the factor of 50 I had hoped for. This shows that a large part of the damping in the system is caused by other factors like the material of the string and the damping in the speakers, and so putting everything in a vacuum.
Yeah, so it just points out that the air isn't as big an effect as the fact that the material itself, the stresses inside the material, the heat being lost, the tearing kind of stuff, the stuff moving in the wrong directions inside the material is using up a bunch of the energy.
Wasn't really a very useful exercise. So I guess practical limitations kept me from demonstrating the analogy for wave energy absorption and make a string switch standing wave mode.
So, it's really sad that, he's got all this hardware. He can do these, kind of complex experiments in this very sophisticated way, and he doesn't prove kinetic energy. Doesn't show us the lever failing to conserve momentum, and he doesn't show us the spring failing to conserve momentum.
Using the beat frequency. But what now if I was not limited by practicalities and could make anything I wanted? What would my ideal setup look like for the demo?
Across the globe, the vast majority of children with cancer will die. Those
Great.
children deserve so much better.
Oh, fuck you in the ass.
Ideally, the set.
I mean, yeah, they deserve to be experimented on, so, grotesque, really. We need more victims to experiment on.
That would consist of a purely elastic string without friction. This string would be indefinitely long to avoid reflections on the ends where we introduce a wave. Alternatively, you could also place damping devices at either one of the end stops, if an infinitively long string is not an option. In this string we create a confinement in which we can introduce transverse waves containing a certain amount of energy. We could create these by switching on a transverse source for a limited amount of time and then switch it off. And since the string is purely elastic, the transverse standing wave would exist forever within the confinement. So now this confinement contains a very specific amount of wave energy. There are two things that I would like to add to this system. First, we want to be able to change the phase and the frequency of the energy contained. And second, we want the energy of the system to be able to interact with the energy.
So I don't really understand exactly what he's after. He wants to inject some counter energy, all right, either a dampening, like you're absorbing some portion of the noise that you want to extract, whatever that would be. But I really don't understand entirely what he's attempting to do, that's useful.
In the space around it. In other words, the system should not be energetically isolated from the rest of space. So how can we achieve both? Well, we could replace the fixed end stops of the contained oscillation with a stop consisting of two wheels. By harmonically accelerating, for example, the left set of wheels in the longitudinal direction, you can effectively modify phase and frequency, and so redistribute wave energy and make one standing wave change into another. These wheels would effectively confine the transverse movement and allow for phase manipulation. But unfortunately, they would also allow potential energy contained in the elasticity of the string to leave the confinement, which would make the transverse wave gradually die out. But wait, what if we could make use of the rotational inertia of the wheels? Inertia would effectively block high frequency potential energy waves and prevent them from escaping, while allowing lower frequency energy to pass in and out of the confinement. And now I feel we're finally getting somewhere with our analogy. So let's think of what each of these components of the model would represent in the world of electromagnetic radiation. And
there, finally, yes. Now he'll try to show us how this has something to do with how light propagates.
Particles. The string would basically represent space, a purely elastic medium for all
whatever that even means. So obviously I say space isn't elastic. The forces in it make matter elastic. So force makes matter elastic.
Energy. It will allow energy to travel around with some maximum speed, but in fact only potential energy stored in the elasticity of space could reach that speed. This maximum speed would be the analog to the speed of light. The confined high-frequency transverse wave would represent the total energy contained in a particle as momentum. The energy would...
So obviously I would say it's just so much simpler to say the momentum of the particle is its velocity in a direction, and you don't need anything more. And obviously all you have to do is put the little bits of energy at a distance from each other, and you can change their frequency that they impact a system of electrons.
Would be proportional to the transverse frequency, and the movement of the wave boundaries would represent the interaction with the electromagnetic field. Energy exchange between this field and the internal wave would only occur effectively at specific beat frequencies having the right phase, because only very specific frequencies.
So I don't know, he's making some argument that somehow the field is going to affect the field photon thingy. I don't know.
Would be stable within the confinement. But what
I thought he was getting to a reasonable point where he's saying, let's just forget about what photons are and let's talk about what electrons are and how they behave. And the fact is they are elastic.
would the wheels and their rotational inertia represent? Well, their role is to make energy transfer between the radiation and the electron possible, and at the same time confine high frequency energy. So the wheels would also represent a property of space. In fact, they would represent some kind of spatial inertia. With this, I don't mean the type of inertia that we generally associate with mass, because empty space apparently does not contain mass. No.
Whatever. So, I mean, just using this, well, I don't mean inertia as inertia. I mean inertia as blah, 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 some other word. Some other completely different concept. Obviously there's mass in space, and it's in the form of little tiny discrete bits of mass moving velocities, and those are hitting us and pushing us into the earth right now.
This type of inertia would act purely by resisting the acceleration of energy. Now, if you think empty space cannot have elasticity and inertia for energy, maybe think again, because...
Oh, please. Yeah, right. Well, think again. Why? Why should I pretend that empty space isn't empty space? It's some sort of jello that's springy. It's just whatever. Why? I don't need to do any of this crap to come up with a rational model.
How else can gravitational waves exist?
Oh, fuck.
The energy
They
inertia of
don't.
space, represented in the analogy by the wheels, would effectively allow low frequency energy to move around freely in space, but would confine any high frequency energy, like the vibrational energy that's present in the electron. Just for fun, let's calculate the frequency of an electron at rest. We can do this by combining Einstein's mass-energy equivalency with Planck's relationship between energy and frequency.
All right. And what the fuck? In their relativistic nonsense world, what does this at rest nonsense even mean, at rest? Go show me the electron at rest. Just more bullshit.
Find that the electron at rest consists of a really high frequency vibration, more than 5 orders of magnitude higher than the frequencies present in visible light. A consequence of spatial inertia would also be that it confines high frequency radiation waves, like that of X and gamma rays, who have frequencies similar to that of the electron. The inertia and elasticity of...
So again, those are, gamma rays are an electron moving very fast, moving into a field of stuff, moving very fast, and it's compressing it every time the electron moves forward. It collects the photons, compresses the space they occupy because they're reflecting at each one. As the movement's really fast, it collects everything. Everything's reflecting but not going very far away as it reflects. So it's all getting compressed, and every time the electron moves very quickly away, there's no reflection. The electron becomes essentially invisible. Nothing reflects off of it. So it's an expansion in the sense of the density is either being compressed or, they use different words for, rarefactions. Yeah. High density, low density of energy quanta.
space together would allow the electromagnetic radiation to shift the frequency of matter. However, for a confined electron which only knows specific energy states, it would mean that only specific frequencies of light will do the job. On top of that, the radiation would have to have the right phase, amplitude and duration to create a change in the energy state. And
right, so that part all makes sense, right? You're going to hit these, you're going to hit electrons in an atomic system, a pressurized system of elasticity, and you can hit the electron in different ways that will either complement motion or destroy it.
this would make the occurrence of energy exchange between matter and radiation fundamentally probabilistic. Sometimes I wish I were a poet.
Oh, this whole probabilistic crap. Again, we know these are. It's a mechanical system. I mean, this is the probabilities are just us making our bad guess. But we know the model is much more discrete than we can actually model. In the sense that this stuff is so tiny. There's no reason to talk about it being randomized in some way because it's not.
Because then I could have told you all this in under
Random.
30 seconds. Matter, a trapped energy wave, stuck between space's rigid embrace in a deep high-frequency cave, a vibrational mode that cannot replace yet yearns to break free.
So what the fuck is that shit? Matter, trapped energy wave, blah 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 blah. Okay, matter is a trapped energy wave? No, it isn't. Matter is electrons and protons stuck between space rigid embrace. So that is stuck in a universe full of little bits of force moving the speed of light in a deep high frequency cave, whatever the fuck that means. I have no idea. Vibrational mode that cannot replace, whatever that means. What the fuck is that crap?
Butting its head with inertial walls, trying to flee as it vibrates and calls. But when enough energy is amassed, again it beats the confinements of space, sending out messages, sometimes, at last, and thereby reveals us its long-hidden face.
Oh, fuck. You haven't revealed anything. You're just propagandizing for a religion. No, thank you very much. La-di-da. So all these people like religion and support religion. Okay, got it. Ugh, fuck. 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 Anyway, moving on. So that's it. So I'll give a couple of minutes to any chatters available. And so, it's a narrow subject, kind of a little bit boring, I would say, because, I don't think it's as complicated as he wishes to make it. It's just little bits of force hitting electrons. They hit them with a momentum vector. The momentum vector is combined with the electron's previous momentum vector. You end up with a new momentum vector. It can be in a direction that adds energy to the wobble of the atoms, or it can subtract from the wobble of the atom. Blah, blah, blah. Not that complicated. What am I looking for? I guess we'll go to this live thing and see how many peoples are here. 9. Well, not great, but whatever. We'll see if anybody has anything to say, and if not, we'll just be on our way once again. Ugh. But it really is, they're so glued to these concepts that, in my opinion, are obviously wrong. Okay, there's just no way to talk about waves in a system as being how photons travel through space. They don't wave their way through space. They're just little BBs, and they fly at the speed of light, and then they hit an electron, they push it. And when that electron is pushed, it's likely there's another electron somewhere around, because electrons don't like to be on their own. And the other electron is going to be pushed. And then there's likely to be another atom associated with that atom. And that pushed electron is going to tell that other atom that its electrons need to be pushed. And, it's just going to push its way through a system, and you'll either add energy to that system or subtract it depending on the frequency with which you poke the atoms. Poke them at the right frequency and they do one thing. Poke them at another frequency and they do something else. Not that complicated. Alright, so it looks like nothing. So, a couple more seconds, and then I'll just say the hell with it. No point in attempting conversation. With the limited audience I'm giving access to. That's what it comes down to. There's just too few people interested. Unfortunately, too few people exposed to the opportunity to participate in the conversation. And that's an internet unfortunate fact. We even lost somebody. But whatever. Yes. It's a very unpleasant, prospect of, this one-way communication thing sucks. And then when there's people two-waying, they're going to be off the subject anyway, so it won't, they'll be not very useful. So anyway, I guess that's it. So we don't have too many sessions where there's 0 comments, but that's what I guess that's what we had. So thank you. I don't have to say thank you, I guess. Thank you for participating. Well, I don't have to say that. Anyway. All right. Till the next time and such and so forth and what.